So two things in 1.7. We've got combinations of functions and function operations. And the first one we'll look at is just function operations, because it's basically just that. You're going to add, subtract, multiply, and divide functions. The very first thing they kind of tell you is that they'll, depending on what they do with these, they'll write these two different ways. That if you have f of x plus g of x, sometimes they'll just put f plus g and just put the x one time. Same thing with a minus. It's f minus g. Multiplication, same thing. They'll just put it into one parentheses. And then division. Now, and of these four, the only one that's got any restrictions on it is the division one. That for this part, they tell you that g of x cannot be 0. Because if g of x is 0, then you're dividing by 0, which means you get an undefined solution, and it's all messed up, and nothing works on that one. So everything else, you can pretty much just do whatever you want to do. The only and usually this isn't an issue. They just say, all right, you just got to make sure that if for some reason you just cannot have it so that g of x is equal to 0. Okay, now, and here's where they'll actually kind of back up for a second. That because of this one division problem, because of this one restriction, they're going to back up and have you do some problems with finding the domain. And basically for this one, you've got two different restrictions you've got to worry about. And the first one, that's really probably the easiest one that we have to do, is that your denominator cannot equal 0. Because if it equals 0, you get the error message on your calculator because you're dividing by 0. It's not possible. Second restriction is that if we're doing square root, because we're throwing square roots at you for this part, that your square root has to be greater than 0. And really what you wind up doing with that part is that whatever the radical is that's here, that really, it's the inside of the radical that you've got to worry about. That's your radicand. Radicand, yeah. Let me write that one in there. So whenever you're doing the square root of whatever the radicand is, then basically you have to have it so that your radicand is greater than or equal to 0. That's probably the better way of looking at it. Yeah, anything 0 and above, we're good. If it's negative, yeah, can't have a negative because negative throws everything off on that one. So anything 0 and up, we're good for that part of it. So what they're going to do in the first few problems, before they even talk about doing all the combinations and the order of operations, everything else, they're just going to give you some functions and say, all right, what is the domain of this function? Okay, so we'll start with 4 over x minus 3. Well, now this one is just there's no radical with it, it's just the denominator. So for this one, you've got to exclude x minus 3 equal to 0. Which, again, add 3 to both sides. So you're going to exclude x equals 3. And depending on how they do this one, they'll either give you, and we'll do two options here, they'll either tell you that it's all real numbers and then they'll give you a box to put in the exclusions, or if they ask for an interval notation, trying to think, because they sometimes they'll flip-flop back and forth, so we'll put both of these here. So we'll say that this is all real numbers, and then we'll say x cannot equal 3. And I'm okay if you tell me it's, biggest thing is you got to tell me that it's all real numbers except for this one number for this particular one. If they ask for an interval notation, again, they kind of go back and forth, so we'll go ahead and throw both of them at you. You're going from negative infinity, you're going to get up to 3, and then you've got to stop because you can't let it equal 3. And if you skip over a number, they're going to put a u in there for the union. And then we're going to go from 3 to infinity. And that's a terrible infinity symbol. That may be a little bit better. The only other thing that they may ask you to do is you may have something like this, where, again, still got the denominator. So we've got x squared minus 2x minus 15. So that's your excluded values that you've got to worry about. And if you have one like this one, where you start with x squared, this is where you've got to go back in and start working on your factoring. So it's the factors of negative 15, where the sum is going to equal negative 2. It's got to be 3 and 5, yeah. And if you haven't done your factoring in a while, just remember that whatever the b term is, that sign always goes with the bigger number. And then to figure out what the other number is, you just divide these two. So it's negative 15 divided by negative 5 makes that a positive 3. So that's x plus 3 and x minus 5. And then for those, just change your signs, because you're going to set both of those equal to 0. So you've got the negative 3, and then you've got the positive 5. Okay, and again, that's what you have to exclude, so depending on how they word the answer on this one. Now, test-wise, here's one thing I will ask you test-wise. Some people just put these two numbers in the circle and they're done. I'm like, well, okay, you gave me everything it's not, so make sure for that one that you go back and tell me that it's all real numbers and x cannot be negative 3 or 5. But you've got to tell me that it's everything except for those numbers. If you just give me those numbers for the domain, then yeah, you got the right numbers, but you're telling me, the opposite of what it should be. In interval notation, we'll go negative infinity up to negative 3. And because there's two numbers, you're going to have to skip around it twice. So I doubt they would ask you to do, bless you, they might ask you to do interval notation on that one, maybe not. What's that? It just depends on what they ask you to do. Sometimes they'll give you the box and you just list exclusions, but sometimes they may make you do interval notation. So it's kind of 50-50. I'm okay either way. If you're just writing it out, I'm okay either way. We're going to do both just in case. Okay, so if you have, sometimes you have more than one exclusions depending on what your denominator is. Let's get you one with a radical here. So let's say you've got 2x minus 8 inside the radical. Okay, this one, there's no there are exclusions on this one, but to get the answer for this part, it's 2x minus 8, and you just have to make sure that thing is greater than or equal to 0. So you're really just solving that equation, or that inequality. Divide both sides by 2, so that's x is greater than or equal to 4. And that one is okay to leave it that way, because that's your inequality. That is telling you that x has got to be 4 or greater. But again, just in case they throw interval notation at you, if it's everything greater than 4, or everything greater than or equal to 4, you're going to start at 4, and then you're going to chase it off to infinity. Okay, so that's kind of the, before we get to all the other stuff, that's the backstory behind getting the addition, subtraction, multiplication, division parts of it. And again, the only thing you have to worry about, anything at all about restrictions, is just on the division one, because you've got to make sure that when you do that one, that your denominator cannot be 0, so that's the only time you have to worry about listing any excluded values when you're going through those. Go for it. All right. All right, so here's where we'll kind of go back and tie it all together here. That we're going to ask you to find f plus g, f minus g, f times g, and f divided by g. And then they're going to ask you to determine the domain for each one of the different operations you've got to find here. Okay, so f of x is 2x squared minus x minus 3, and then g of x is just x plus 1. Okay, now, and one thing, I may have forgot to put these back here. When you're doing this, if you've got room to go back up here, kind of put these in. When you're doing f plus g and f minus g, you're really only, when they ask you to work through these, you're really only going to do one thing. Is you're just going to combine like terms. That's all you're going to do. That no matter what else they do, that's all you can do if you're doing addition or subtraction. You're just going to combine like terms, just add, subtract, and that's all you're going to do. For multiplication, this one is what it sounds like. It's multiplication. It's mostly going to be doing the full method. You might get lucky and have to do maybe just distributive property, but more than likely you're going to be doing the full method. And when you're doing division, that one is you're going to factor and cancel, if it's possible. And it's about 50-50 as to whether or not you can factor these. Some of them you'll be able to factor, some of them you won't. So it just kind of depends on what you're going to do with them here. So this is really when we're getting ready to do these next operations in here. That's what we're going to do. Add and subtracting, you're just combining like terms. Multiplication, more than likely, is going to be the full method. And then if you do division, it's going to be a little bit of factoring and canceling. Sometimes you don't do anything. You just write it down and just tell me the restrictions, and then you're good to go. But that's worst case scenario. That's what we're going to do. Okay, so let's go through these. If we're doing f plus g, that is 2x squared minus x minus 3 plus x plus 1. Now, in addition should be the easiest one that you do, because there's nothing you have to do that's really hard with this one other than just combining like terms. Technically you would, but with addition, because addition, there's nothing you're going to change. So there's really, with addition, yeah, there's no point in doing it. Yeah, they may show it to you that way, but there's really, no. Subtraction, yes, you definitely want to do that one, but addition, there's really no point to it. You've got a negative x plus an x. That's a 0x, which just means that part's going to go away. And then negative 3 plus 1 is a negative 2. So that is 2x squared minus 2. Now, on the answer at the end, you don't have to factor, you don't have to distribute out the 2, just give me the answer, and that's all you have to do there. And if you want to go back and put a 0x in there, you could. Because I've had people before, they'll do 0x, and they go, oh, well, I don't need the 0, I'll just get rid of it, and they'll just put an x there, and I'm like, well, no, because if you put an x in there, it's understood that you're putting a 1 in there. So if it's 0x, just make sure that when it's 0x that's in there, that if you take the 0 out, make sure you take the whole thing out. And your domain. There are no fractions. There's no square roots or anything on that one. So unless there's any kind of fractions or square roots, it's just going to be negative infinity to infinity. You can take any number you want to plug in there and you're good to go. Okay, so f plus g is it's the easiest one to do because there's really nothing that's tricky about it. Subtraction, you have to be a little bit careful with subtraction. And there's only one thing you have to be careful of. First part's good, there's nothing you've got to do with this one. But because of the minus that's in front of this, you've got to change all the signs. I think that was going back to one of the questions I think you were talking about earlier. Is that with the minus in front, you've got to change both of these signs. So yeah, you're still going to have the x, you're still going to have the 1, but you're going to change this so it's going to be a minus x and a minus 1. That with subtraction, you're always going to change the signs of whatever that second function is that you're subtracting. And once you change the signs, now you're going to combine like terms again. So 2x squared is good. And if it helps on these, when you have an x by itself, if you want to go back and put 1s in front, you can always do that. Because if you've got a minus 1 and a minus 1, that's going to make that a minus 2. And then negative 3 and a minus 1 makes that a negative 4. And your domain, same thing. There's no fractions, there's no denominators, there's no radicals, so it's still negative infinity to infinity. Negative 1 minus 1 will get you a negative 2 with the x's. Yeah. Okay, when we do multiplication next, this one's got, I won't say it's a little trick, but it's one little trick you can do with some of these with multiplication. That with this multiplication, you are going to do the full method. Now, the difference on this one is that there's 3 terms in this one. So this one you can actually, now if you want to go back and do the full method and have, instead of 2 arrows drawn, you'll have 3 drawn out when you're going through these, you can. But if they give you something that's more than just 2 terms, here's an easier way you can kind of do this one. You can actually do this like an old long division math problem. That you can take this plus 1 and multiply this plus 1 times everything up here, which means if you're multiplying by 1, you're not really changing everything. So it's 2x squared minus x minus 3. Then we're going to go back and do, if you were doing 497 times 23, we're going to do the same thing, that you're going to take everything here and multiply 3 times all this stuff to get your numbers. We'll put that here. Then we're going to do the same thing with the x term. And just like you would do this with multiplication back here, you'd have your placeholder that you basically kind of blot this out. Multiplying by x, if you'll line these up, it makes everything kind of line up neater. If you do 1x times negative 3, that's negative 3x. 1 times negative 1 is a negative 1x squared, and then 1x times 2 is a 2x to the third. And that way, instead of everything being all out, you got to combine terms and drag this and pull this over here. Everything gets lined up, and now you've got everything lined up to make it just a nice, neat, and subtracting problem. Then 3 is good at the end. You've got negative 1 minus 3, that's negative 4. 2 minus 1 is 1, x squared, and you've got your 2x to the third. And I think if you put the 1 in there, I don't think the computer's going to like that 1, so you do want to go back and take that 1 out. Now, if you want to do the full method, you can do that, but the only difference is you'll get these same numbers. They're just going to be spread out. They're not going to be in order. They're going to be all over the place, and sometimes it's easy to kind of lose them as you're trying to combine like terms. So if you get one like this where you've got, and you could even do that with the full method, it's just it's so short that it doesn't really is any benefit doing it that way. But if you have more than 2 terms in the full method, it's easier if you stack it up and do it more like a multiplication problem, where you do 7 times 3, make it 21. That's 29, and that's here. When you multiply by the 2, again, you're going to put the space holder in here. 2 times 7 would be 14, and just keep going through the numbers there. So it's got the same basic setup that you can do this one. That way, especially if you start multiplying 4 and 5 terms, it's a whole lot easier to do it this way than it ever is to do the full method, because you just got arrows going everywhere. It's just easy to get lost there. And the main for this one, no fractions, no radicals, so still negative infinity to infinity. All right, and division. Here we go. Here's the one where we actually do have one restriction we've got to worry about. We've got 2x squared minus x minus 3 over x plus 1. Okay, and this one's got a good part of it. Now, if you want to, we can go ahead and get the domain part out of the way. Because it's all real numbers. But we're not going to use x plus 1 equals 0. So your domain would be all real numbers except for negative 1. Okay, and for that particular problem, that's the easiest part to get out of the way. Because once you set that denominator equal to 0, we're going to exclude that one number because it's just x to the first power. We've got everything we need. So there's our domain when we're going through this one. Here's where the factoring kind of comes back, and this is a tougher factoring if you haven't done this in a while. But if the first term, and basically here's where you kind of get this, is that can you factor? Now, there's nothing you can do to factor the bottom. It's x plus 1, so there's nothing there. But the problem becomes, if you start with x squared, is can you factor this one? And if you haven't done factoring in a while, here's where we're going to show you something that, again, everybody's done this different ways, and everybody's got a different trick to it. But it's similar to what we're doing. This is where you have to do the AC method, because this first term is something other than 1. Kind of complicates it a little bit. If the first term is something other than 1, what you have to wind up doing is you've got to multiply 2 times negative 3 to make it negative 6. So now we're looking for the factors of negative 6, which still equal this middle term here where the sum is going to equal negative 1. Okay, it's not going to be 1 and 6. But it could be 2 and 3, right? Because if we do 2 minus 3, that would be negative 1. So if we put the negative here and a plus there, 2 times negative 3 is negative 6, and 2 minus 3 is negative 1. All right, now here's where everybody does something a little bit different when we're doing factoring. And if you didn't do it this way, that's fine. Because everybody's got their own spin on how they do this one. This is something I've taught it different the last 2 or 3 years than I did the first 10 years before that. That depending on, and some people do it differently. Some people will have you do the regrouping method where you're going to take the middle term of negative 1 out and you'll replace it with 2x and minus 3x. Then you've got your 4 terms. You can do factor by grouping and then go from there. Okay, so if that's the route you go, that's fine. Here's something that somebody actually had one of the kids show me this one time. And it took me a while to get used to it. Once I got used to it, I kind of liked it better. take the same numbers you've got, the x plus 2 and the x minus 3, go ahead and drop those down. Because here's where you have to kind of balance this out. In the beginning, we multiplied by 2. So the numbers are too big. So because we multiplied by 2 in the beginning, now you can go back and just divide these numbers by 2. 2 divided by 2 is 1, so that makes that x plus 1. And for this one, 3/2 is a fraction, you can't simplify it. So here's the trick to get this back. We call it the bottoms up method, because if you get to this point and you've got a fraction, just pull the bottom number up in front of x. And there's your factoring part right there. Now, and everybody's got something different that they've called it. I used to teach it this way, where you would take the middle term out and replace it. If you did factor by grouping, then you would have 2x here. Sorry. Yeah, both of them have a 2x. You're left with an x here. 2 divided by 2 would be a 1. This one you can take out a -3. And then you pull these two terms together to get 2x minus 3 and x plus 1. So, and there's probably 2 or 3 other different ways that people have done factoring. If that first term is something other than 1, there's all kinds. Now, they're all very similar, but there's all kinds of different nuances you can get through those. If you haven't seen that in a while, if you want to come back at the end of class, I'll come back in and give you a little bit more detail. But basically for this one, we factor this thing out, we can get these two answers. So that the problem becomes x plus 1 times 2x minus 3, and that was over x plus 1. And then your x plus 1s will cancel. So then your final answer for this one would be 2x minus 3. Now, and we had the restrictions, and again, the easy part for this one was back up here in the beginning. We had our domain back here, because that was the easy part that we did, because we just took this part and excluded x minus 1 equals 0. Now, those are 50-50. Sometimes you'll get these where you can factor. If you get one in the beginning and you look at it and you go, it won't factor, you're done. You don't do anything at all other than you just plug this in, and that would be your answer. This is one where, worst case scenario, it does factor, you get some stuff you can cancel, and there's your final answer if you're trying to simplify that one. Now, good news is, you won't get a lot of those where you're going to have to do the multiplying and the bottoms up, but just throw that one out there to you so that if you do or don't remember that, that will pop up a little bit as we go along. Won't be a lot, but every now and again it'll pop up on you. All right, let's do one more of those, or we'll go through and do the addition and subtraction on these. And for this one, let's do some radicals. Okay, so let's say that f of x is square root of x plus 4 and g of x is square root of x minus 1. Okay, and with the radicals, it works out pretty nice, because when you add these together, there's really not much you can do, because if you've got the square root of x plus 4 plus the square root of x minus 1, there's nothing you can do to add and subtract those. That's it. That is your problem there. All right, now when you get to the domain part on this one, here's where you're going to kind of look at it, because the domain on this one, instead of starting at 0, we're going to go 4 in the opposite direction. So this one, you're going to start at -4 and go to infinity. This one, you would start at 1 and go to infinity. Okay, so for domain on this one, you can start it, I guess the question is on this one, if you start at -4, this one's okay, right? But what happens if you put a -4 in here? What's the square root of -4 minus 1? Be square root of -5, right? Can you take the square root of a negative number? Can't, can we? So this one, we get to start at 4, -4, but that's not going to work in here. So until this one's okay at -4, this one's not. So this one's going to kind of trump this one because this one works here, but this one doesn't. So basically the domain on this one is we're going to start at 1, and then we're going to chase this thing up to infinity. So if you have two different square roots that you add together, you've got to kind of figure out which domain you're going to work with, because you got to figure out, okay, does this one work in both places, or does this one work in both places? You got to find the one that fits both of them. Now the good news is, when you do subtraction, it is the exact same answer. You just change this from a plus to a minus, and your domain is still going to be the same thing. It's still going to be 1 to infinity. Okay, with multiplication. Now this one you actually do get to multiply these together. When you do the square root of x plus 4 times the square root of x minus 1, you're going to do the square root of x plus 4 times x minus 1. That even though it's square roots, you're still going to go ahead and do the full method. You just have to do the full method of what's on the inside of the square roots. So that would be the square root of x squared. You're going to have minus 1x plus 4x minus 4. And again, your middle two terms for this one, you can combine those two. So that would be x squared plus 3x minus 4. Now, and because you started with the same two square roots, you're still going to basically have the same thing. Your domain is still going to be 1 to infinity, because you still have that same problem that if you put a negative number back in here, if you put in -4, it's still going to mess things up. So your domain is still going to be the exact same answer. It's still going to be 1 to infinity. Did I do something wrong? Oh, because when you do the L part, you got 4 times -1. Go ahead. When you can include that number. And the difference is basically on these two. If you're doing radicals, because of how this one sets up, says you can use 0, that for the radicals you'll start with a bracket on that number. And for the fractions, it's going to be parentheses because you cannot use that number. So if you go back to the graphs, it's that open circle and closed circle option. That if it's the open circle, that's going to give you a parentheses. If it's a solid circle, meaning you can use that number, that's when you start with the bracket.
So like 4 is like x not equal
-1. That's an open circle, because you can get up to -1, but you can't touch it, because if you make it -1, then it messes up the problem. Yep. And this one, because you actually get to use 0, 0 is okay. You can take the square root of 0. So this one, anytime you're doing square roots, you actually get to start with that number, and that's why it's going to have the square bracket on it. Okay. Okay, and then the last one. What was it? Go ahead. Oh, that was just saying that whatever this number is that's here. Yeah. You know, if that was 2 or 3 or 5 or whatever it was, yeah. Okay. Okay, if you do f divided by g, that's square root of x plus 4 over the square root of x minus 1. Is that what we're doing? Yeah. This one, there's nothing you can do because the only way that these can cancel is these two things have to be identical. There's nothing you can do to factor this one. There's nothing you can do to factor this one. So that's your answer. And the same thing with your restrictions is your domain. It's going to be the exact same answer. It's going to be 1 to infinity. So once you get one domain, you're pretty much good for every domain when you go through those with the radicals. Okay, so that's the options you get working with the add, subtract, and multiply and divide. Now, if they give you some of these, they may give you some easier problems back up here instead of starting with x squared and x to the thirds and all those other ones. Just kind of give you a worst case scenario because this one we still run through the options of, you know, combining like terms and doing the full method. That's the biggest thing you've got to kind of go through on those. Okay, and then the last thing you've got to do is what they're going to call composition of functions. And I'm at the end of the page. Let's get you the page here. And with this one, this is where you're actually going to take one function and plug it in for the variable in another function. And there's two different ways that they'll show working through the compositions on these. It's kind of like the other part that they'll go for this one. Now, it looks like it's FOG-X because it's F-O-G. But it's basically, it's a multiplication dot, but it's an open circled multiplication dot. And that one, they may write it that way. They may also write it with a double set of parentheses. Or look something like that. Okay, now here's the big thing with this one is that because g is closer to the x in this part of it, when you have one like this with its f of g, this means you're going to plug g of x into f of x. And I remember when I first started doing this one way back when, that I had trouble with this one, and when I actually would write out the words and actually start going from there, everything kind of clicked with me. If I tried to do it in my head and tried to make sense of it without writing it out, I got lost all the time. So I actually had to write out the words, and once I did that, I was good to go. If you reverse it around and do the g of f, golf x without the L, if you do the double set of parentheses, it would look something like that. This one is the opposite. This one you're going to plug f of x into g of x. Okay, so let's give you a couple of these examples so you can kind of see what's going on here. So f of x, let's make it be 4 minus x, and g of x will be 2x squared plus x plus 5. And these, they don't worry about domains on this part because it's a separate kind of problem than the addition and subtractions and the multiplication division. So these, they say, all right, don't worry about domain. We're good to go. We're just going to kind of plug it in. And they should ask you to do probably both of these. They should ask you to find g of f and then f of g. So we're going to find FOG-X first. or f of g. Again, for me, this is, when I walk through these, this is what I had to do, because when I first started doing it, I would get lost, and doing this part can help me out. Whatever's closest to x, that's the one you're going to start with. So we're going to plug g of x into f of x. And for me to get through this one, I actually wrote out that sentence so I could kind of see it, and then from there I just wrote down what the functions were. This is 2x squared plus x plus 5, which is my g of x, and that's got to go into 4 minus x. So this whole thing goes in for x. Or they may put, yeah, or if they do the double parentheses, it would look something like that. Either one of those two there. Yep. And they sometimes they'll flip flop and go back and forth on those two. Okay, so when you plug it in, it is 4 minus, and then take out the x, and you're going to put this in place of x. And then once you take that function, whatever it is, in this case g of x plugged in f of x, you've got to work it out and see what you can do. And most of the time it's 50-50. One's going to be easy. One's going to be a little bit more complicated. This one's going to be being the easy one, because when you plug this one in, there's only one thing to do. You're just going to distribute out this negative. Make it a negative 2x squared minus x minus 5. Well, the only thing you can do is do 4 minus 5. So that's going to be negative 2x squared minus x, and 4 minus 5 is negative 1. And that would be the final answer that you get for f of g of x. Okay, so if they give you, and again, most of the time if they have you do these, you're going to have one that's going to go pretty easy. The other one's probably going to make you slow. No, not always, but most of the time you're going to get one that's a little easier than the other one. When we go the other route, well, let's go the opposite here. Let's go g of f. This time we're going to plug f of x into g of x. And again, they may write it like this. They may also have it so it's written like this. So either one of the two, depending on which way they do it here. Basically, the g is first or the f is first. Is kind of what you're looking at. So f of x was the 4 minus x. And that's got to go into x squared. Sorry, 2x squared plus x plus 5. Now this is the one that's got a little bit more work, because there's 2 x's to plug in. We've got to plug it in here for x, and we've also got to plug it in here for x. This means that becomes 2 times 4 minus x squared plus 4 minus x plus 5. Okay, and this one has a lot more work to do with it, because the other one we just plugged it in and changed the signs. This one you're going to have to do the full method on the beginning. Now, and most of the time we're used to seeing the x terms first. This one, the x term is second. So you may want to actually, instead of trying to do it in your head sometimes, especially if the order is a little bit off and it looks a little funny, you may want to go back and go ahead and do the full method part of it first and actually write it out. That you've got 4 times 4 for 16. 4 times negative x would be a negative 4x. You've got another negative 4x. And then x, negative times negative would make that a positive x squared. And the one thing you've got to remember is that as you're doing that, that 2 was still out front, so it's still hanging out there. So we've got 2 times. Okay. Now that we've got an x squared, let's go ahead and put that x squared first. You've got a -4 to make it a -8. That is a positive 16, so let's get it rearranged where it's what we're used to normally seeing. Everything else back here, there wasn't anything else to do, so these terms are just kind of hanging out back here. The parentheses doesn't help us out, so in that case we didn't have to do any distributive properties, so we don't need the parentheses. Yeah, we can go ahead and make that a +9 there, so let's go ahead and take that -x plus 9. And then we've still got to do distributive property with a 2, so we've got 2x squared minus 16x plus 32. Okay, and then one more step, now we've got to combine all the like terms again, so we've got a 2x squared minus 16 minus 1, and again it wouldn't hurt to put that 1 in there. So -16 minus 1 is -17x, 32 plus 9 is 41. A lot of work, yeah. So, in most of the problems that you do, you get a trade-off. You're going to get one like the first one where it's easy, you just plug it in and it's not too bad. Then you're going to get one like this where you've got a lot of work to do. So they kind of, you know, they kind of spread it out. One easy, one hard. Okay, let me show you, and there's one other thing they're going to ask you to do, and if we get time enough, we'll show you another example of some of these. The one other thing they're going to ask you to do let's see which one do we want to do. It doesn't matter. Is they're going to ask you to find g of f of 2. Take the same 2 functions we've got, they're going to ask you to plug in 2. You've got 2 options on this one, what you can do here. If they make you do the work, and again, I know in the book, with examples they get here, they make you do both of these parts first, and then they'll come back and give you this number at the end. On the online homework, I think sometimes they'll just ask you to find this as a whole separate problem. So it kind of depends on how they do these. But basically, here's what you can do. And we'll kind of do it so that if it's kind of both options here. If they've already made you find g of f of 2, if they already ask you to find g of f of x, which in this case they did, just plug in the 2. Yep, to that answer that you had. So it depends on, really, this is one of those questions where what they ask you to do first can make the work easier depending on how they ask you the question, I guess is what it comes down to. So back up here, what was g of f of 2? That was the one we just did, right? That was this thing. This was 2x squared minus 17x plus 41. So all we're going to do to find g of f of 2 then is just plug it in right here. It's going to be 2 times and then 2 squared minus 17 times 2 plus 41. Okay, so if they've made you do, here's the thing, if they've made you do all that work to get there, go ahead and take the answer that you have and just plug it in. Work it out and see what you get. So for this one, you've got 2 times, 2 squared would be 4. 17 times 2 is 34 plus 41. So that's 8 minus 34 plus 41. Plus 34, that's what, negative 28 plus 41, that should be 13. That's a terrible proof. Okay, now if they didn't do that, if they just gave you a brand new problem and said find g of f of whatever the number was, and gave you two brand new functions on this one, we'll kind of do it this way. And we'll make this short just because, I mean, it doesn't matter how we set this up, but just something short would be fine. Did I mess up? Oh, that is 24. Thank you. All right, back up there. That's 24. Yeah. Because 8 minus 34 would be 26, right? And then plus 41 would make it 15. There we go. Not 13. Thank you. Okay, so let's say you've got a brand new problem, all brand new functions, and now they're going to ask you to find, let's do f of g of 8. Just throwing out some number there. Okay, now, if you have one like this where they don't ask you to do the f of g of x first, here's basically what you can do. It's a two-part problem. So if you're not asked to find f of g of x first, now you could go back and do it, but you're kind of on that 50-50 thing of, okay, am I going to get the easy one to do, or am I going to get the hard one to do? So it kind of depends on how this thing's set up, and you don't know until you plug it in and work it out. So if they don't ask you to do all this other stuff first, just treat this as a two-step problem. So the first thing you want to do here is find whatever 8's closest to g. So find g of 8 first, because that's what it's closest to. So we're going to get that out of the way first. So g of 8 would equal, and again, not too bad, 8 squared minus 2. 8 squared is 64, minus 2, that would be 62. Okay, so we're finding this part of it first because that's what we're closest to. Okay, second thing you're going to do is, now that this part is gone, we're taking g of 8 out and replacing it with 62. Well, now you're just going to find f of 62. Because once you've got the g part done and that's gone, well, now we're going to take this 62 and plug it in for x up here. So if that was x plus 3, that's just going to make it 62 plus 3, and that would make it 65. And that would be the final answer that you're looking for. So if they, and again, it kind of depends on how they ask the question to start with. And some people would, sometimes they just want to get in the habit and they'll say, well, I'll just do this every time. And that's fine. You can do this, even if they give you back up here, if they had given us where we did this problem, if you didn't have this part of the answer and you just wanted to find f of 2 first, and then take that answer and go back and plug that answer back in g, you could have done that too and get the same answer both times the same way. To me, it just depends on what they ask you to do ahead of time. If they've already asked you to find f of g of x and you just got to plug the number in, usually it's easier to do that because you've done all the work anyway to get you to that point. Probably not in this case. But again, if they did, there's no square roots, there's no radicals, so it would be all real numbers. Yep, infinity to infinity. Okay, now they do actually give you some with some fractions. Let's do one of those real quick. This one we'll just find one. Let's find f of g of x in the domain. Okay, so f of x is 2 over x plus 3, and then g of x is 1 over x. Okay, so we've got to find f of g of x, and again, the way this thing is written with f of g of x, that in my mind I'm thinking that I've got to plug g of x into f of x. And don't let the fractions scare you. It's still the same setup. We may have to clean it up a little bit at the end, but it's still the same setup when we're going through these. So g of x is 1 over x, and f of x is 2 over x plus 3. So this is going in place of x right there. Okay, so that's going to get us 2 over. When we plug in that for x, that's 1 over x plus 3. Okay, now here's where one of those things where that's an okay answer, but they haven't really talked about, they didn't talk about complex fractions. That with that answer, it's basically, it's a complex fraction because you've got a fraction inside a fraction. And they normally don't like that. They kind of like for everything to be gone so that there's just a numerator and a denominator, where this one we've got a numerator up here that's fine, but down here we've got a denominator mixed in with a denominator that's already there. So they kind of say, all right, well, here's what we've got. We don't really like the way this thing looks because it's a complex fraction. We've got a fraction inside a fraction. So if you have one like this, what you've got to do is you've got to multiply all the terms by, yep, So you're going to multiply, and that's the key thing. It's got to be every term. It's not just the ones in the denominator. You got to multiply all the terms by the least common denominator of whatever this whole thing is. In this case, it just happens to be x. So we're going to take everything that's here, this 2 over 1 over x plus 3, and you're going to take every single term and multiply it by x. Okay, top part, real easy. It's just 2 times x, it's just 2x. And here's the thing, is that on the bottom part, because we've got this fraction that's already in the denominator, we want it just to be whole numbers. These x's have canceled, that's going to leave you with a 1. That's just 3 times x. So that's 2x, and that's over 1 plus 3x. And that would be the answer that you're looking for. Now, and the good thing is, when they're doing these, the fractions that you get, if you do happen to get a complex fraction like this one, it should usually just be that one term that's here. They're not going to make it so that you've got 18 different fractions. No, it should just be that one denominator you've got here. That should be your least common denominator, because they haven't talked about complex fractions, and they just kind of snuck that in there. So you just got to kind of know that if you do get a fraction answer, that's the one thing you got to kind of take care of it there. Okay, in the main part, that's our answer. So we've got to say it's all real numbers, or we're going to exclude. Yep, 1 plus 3x equal to 0. So that was the answer we had. We've got to take everything out except for that one little part of it there that's equal to 0. Now I'm going to check one thing real quick. Sometimes they'll do something here. I'm going to see if they did it. I think this one may have a 2-part answer. Actually, I think it's got a 1 part. Let me check something real quick. I think they may actually tie this one back into the original part of it. Okay. So there's our answer. We're going to exclude that part. Here's the other part where they're going to tie this thing in. If you go back to the original functions, well, let's go ahead and get this part first here. Oh, what am I doing? Hang on. So we're going to subtract the 1. negative 1/3. Okay, now here's where they hit both parts, because this was, if we back up for just a second, this was the final answer that we had here. But before we did that, this was our answer that we had. So they kind of go, all right, well, this was the answer we have now, but this was the answer before we simplified it. That back here, what made this thing mess up? The 1 over x equals 0, right? So they're going to make you do two parts, and that's why I don't necessarily like this question. They're also going to have you exclude that this was 1 over x equal to 0. Because before we cleaned it up to make it look like this was actually our answer, and here's where this denominator would mess up and make this one 0. So they're going to make you basically kind of bring in both parts. That we're going to exclude this one, and we're also going to exclude this part. Which means that you also have to exclude x equal to 0. So this one's kind of, because we changed our answer from what it originally was, we've got what this one was back here, but then we've also got what this one is here when we kind of bring this thing together. So it's, because we had the original answer and then we changed it to make it look like this, we got to bring in both parts because it was this, but now we changed it to this, so we still got to kind of pull both of them in there. So, if you kind of set this one up like cross products, well, I guess the best way, oh, hang on, back up a second. Because if you've got 1 over x equals 0, you've got to exclude your denominator equals 0. So all you're worried about in this case is just the x that's here. Because it's still, because it's a fraction, right? That all you have to worry about is just your denominator, and you've got to exclude that part of the denominator equal to 0. Right. So yeah, and I should have. Let me just take that 1 out there. There we go. Let me do it that way. Right. Yeah. Yeah. So you're going to exclude two different numbers when it comes down to this one. So, you know, if they were asking you, this would be all real numbers. You cannot have x equal to 0, and you also cannot have it so it's negative 1/3. Okay, so fractions are just all kinds of fun, because there's all kinds of stuff you've got to worry about when you're going through this. Okay, we've got 4 minutes left, and that is just enough time not to really do much of anything. So we'll pick back up. Now, section 8 next time. We'll start there.